Now we'll come to the last part of this particular chapter, that is buffer solution. Buffer solution. B-U-F-F-E-R. Buffer solution. Now what is a buffer solution? Buffer solution is a solution, you can write it down. A buffer solution is a solution which resists any change in its pH, which resists any change in its pH, that is, whose pH remains practically constant. The pH value does not change, it remains practically constant, or if at all it changes, minute change we can say that, very small amount of, like suppose the pH is 7.3, you get it 7.31 or 7.32, that's quite a negligible change, we can say that. Again I repeat, a buffer solution is defined as a solution which resists any change in its pH value, that is, whose pH remains practically constant even when small amount of the acid or the base is added to it. Even when small amount of, this is a very important word, small amount, not large amount. If you add large amount of acid or base, then definitely it is going to change, the pH is going to change. Even when small amount of acid or base is added to it. Again I repeat, a buffer solution is defined as a solution which resists any change in its pH value, that is, whose pH remains practically constant even when small amount of the acid or the base is added to it. When small amount of acid or base is added to it, still then the pH remains it remains constant, the pH does not change. So that particular solution is called as a buffer solution, so to say, we can say that. Now, buffer solution generally is used in pharmaceutical industries to prepare medicines. Your blood is the best example of buffer solution. Then seawater is an example of buffer solution. Why we say the blood is the best example of buffer solution in our body? Because we are taking different kinds of food. We are taking acidic food, basic food, neutral food, different kinds of food. Does the pH of our blood change anytime? No. And mind it, if the pH of your blood is going to change, means that will be the last day for you. Got it? So pH of the blood is slightly alkaline in nature. The pH remains constant. If slightly the pH also means, suppose if the pH tries to change, then you suffer from many diseases. Got it? Especially you suffer from diarrhea, you suffer from cholera. Got it? That is the, what you can say, the digestive diseases you suffer from. We can say that. So in this way, what we find is that many different kinds of food we are taking it, but the pH of our blood remains almost constant, we can say that. If at all the pH changes, then you suffer from many diseases, we can say that. But generally it does not, we can say that. Generally it does not. It resists any change in its pH, we can say that. Fine. Now next is, I said you seawater is the best example of buffer solution. Now in the seawater we are throwing so many substances. So many industrial waste, human waste, animal waste, different kinds of substances we are throwing into the seawater. But does the seawater anytime it becomes, what you can say, sweet, or it becomes neutral from salty? No, the seawater remains as it is. It is salty only. It remains salty only, even if so many substances is being added to it. Got it? So that is an example of buffer solution. Your medicines, all liquid medicines, the syrups and all, they are all coming under the buffer solutions, we can say that. Because the main purpose of those medicine is to act upon that particular, what you can say, disease. It's not going, it should not change the pH of your blood. The main purpose is to act upon that particular disease and to cure that disease, not to change the pH of the blood. That is to be remembered. Got it? Clear? So based upon that, we are having two types of buffer. We are having acidic buffer and basic buffer. Acidic buffer is what? It is a solution of mixture of weak acid and its salt with a strong base. What I said, it's a solution of a mixture of weak acid and a salt of weak acid and a strong base. That is what I said you. It's a solution of mixture of weak acid and its salt. Its salt means the salt of weak acid. So salt, how will you make it? Of weak acid with a strong base. You will make the salt. For example, CH3COOH plus CH3COONA. It's an acidic buffer. Similarly, HCOOH plus HCOOK, acidic buffer. H2CO3 plus Na2CO3 is an acidic buffer. We can say that. Clear? So, an acidic buffer means it's a mixture of weak acid an equimolar mixture of weak acid, rather I should say an equimolar mixture of weak acid and its salt with a strong base. That is called an acidic buffer. Similarly, basic buffer. It is an equimolar mixture of weak base and its salt with a strong acid. Weak base and its salt with a strong acid. Weak base like NH4OH plus NH4Cl, we can say that. We can say calcium hydroxide plus calcium sulfate. We can say magnesium hydroxide plus magnesium nitrate. We can say that. Okay. So in this way, what you find is that a salt of weak base, and that is a weak base and its salt with a strong acid is called as a basic buffer. We can say that. That is known as a basic buffer. I hope you are following what I am saying to you. Next is buffer action. We can say that. What is buffer action? The property of buffer solution to resist any change. The property of buffer solution to resist any change in its pH value. Any change in its pH value, even when small amount of the acid or base is added to it, is called buffer action. Alright, what I said? It is the property of the buffer solution to resist any change in its pH value. Any change in its pH value, to resist. Alright, when a small amount of acid or base is added to it, that is called buffer action. Suppose you are adding small amount, mind it, not large amount. If you add large amount of acid or base, definitely it will not behave as a buffer solution. It will become as an acidic solution or a basic solution, so to say. So when small amount of acid or base is added to it, then hardly, the pH changes. Minutely, the pH changes. So that is called as buffer solution. So the capacity or the property of the buffer solution to resist any change in its pH value. So definitely buffer will not allow, the solution will not allow to change its pH. So that is called as what? That is known as buffer action. Alright, when a small amount of acid or base is added to it, what you find is that the pH does not change. Or if at all it changes, hardly it changes. So that is called as a buffer action. We can say that. That is known as a buffer action. Now, how can we say that a particular solution is a buffer solution? How will you prove it? It may come in your exams. A particular salt will be given to you and you will be asked to prove that it is a buffer solution. Okay, let us prove it. For example, ammonium acetate solution, we will say it is a buffer solution. Ammonium acetate. That is CH3COONH4. I have to prove this solution is a buffer solution. So how will I do it? So first I will write the equation CH3COO minus plus NH4 plus. Alright. Now upon first case, what will I do? I will just add a strong acid to it. Strong acid. Let us say HCl. It will dissociate completely. H plus Cl minus. So what will happen? That is CH3CO minus from the buffer solution. CH3CO minus, you can see that this will react with H plus ion from the acid, because this will dissociate almost completely. This will dissociate almost completely. Alright, because it's a strong acid. So hence it's a strong electrolyte. So it is going to form undissociated CH3COH. Listen carefully. So in the first case I am adding HCl to it. On adding HCl, it dissociates completely into H plus and Cl minus. Small amount of HCl I am adding to it. Small amount, mind it, that word has to be used. So now CH3CO minus ion from the buffer, from the solution, and H plus ion from the acid reacts to form undissociated. This is undissociated because you know acetic acid is a weak acid. So it will dissociate again very feebly. Very feebly it is going to dissociate. So we can call it as undissociated only. Undissociated molecule it is going to form. We can say that. It forms an undissociated molecule. Or if at all dissociates, it dissociates very feebly, mind it. So, which will not change the pH of the solution. Alright, fine. Now the second case, what I am going to do, I am going to add, that is a strong base. Like let us say NaOH. NaOH on adding gives you Na plus OH minus. Alright, now what will happen? NH4 plus from the solution, we can say that, NH4 plus from here, reacts with OH minus ion, to form again undissociated NH4OH. It is an again undissociated molecule of NH4OH. We can say that. Again, NH4OH, you know, it's a weak base. It forms an undissociated molecule of NH4OH. Due to which, again, on addition of small amount of base to it, the pH of the solution remains almost constant because OH minus value is not increasing. H plus ion concentration is not increasing. The concentration of OH minus ion and H plus ion, because small amount I've added, mind it, small amount of acid and base I've added. So hence, and that also is being used up in the formation of acid and a base, which is a weak acid and a weak base, which is undissociated molecule. Got it? So what you find is that the pH does not change, because what I said, that concentration of H plus and concentration of OH minus remains constant upon addition of small amount of acid or base to it, due to which CH3CO NH4 acts as a buffer solution. In this way, any particular solution will come in your exams, any particular example is going to come in your exams. You take in this way, and strong acid, let us say HCl, strong base, let us say NaOH, and you explain it in this manner. You have to explain it also as I explained you. Alright. So in this way, you write it down, this one what I said you. Alright. You make it a note and make sure that you have understood it. You can take any other example and you can do that. Now, next is we will see the buffer action of acidic buffer. Alright, of an acidic buffer. So, what happens is that in case of buffer action of acidic buffer, what it happens? Okay, fine. Now, for example, acidic buffer I will take, that is your acidic buffer I will take, that is your CH3COOH. It dissociates to give you CH3COO minus plus H plus. You know that. Alright. Now, acidic buffer means it's a salt of, it is nothing but weak acid and it's salt with a strong base. So, let us say CH3COO-Na. It will dissociate to give you CH3COO minus plus Na plus. Now, you can see there is a common ion. This particular ion is a common ion. This ion is a common ion. You can see, due to common ion effect, what will happen? The concentration of the product is increasing. Due to common ion effect, the concentration of the product increases and the equilibrium is favored in which direction? Backward direction. The equilibrium is favored in backward direction. That is CH3COOH, and hence it acts as a what? A buffer solution, so to say. Even if you add an acid to it here, small amount of acid or base, then also the pH does not change. Let us see. Let us add it and see. Same thing. Let us add it and see. Like let us say I am taking HCl. HCl will dissociate to give you H plus and Cl minus. Now this common ion, got it? This common ion, that is CH3CO minus, got it? Will react with H plus ion, got it? To form what I said to you just now. I said that it will form undissociated CH3COH molecule. Will it change the pH? No. This common ion, CH3CO minus ion, reacts with H plus ion, got it, to form undissociated from H plus ion, from where it got? From acid, strong acid, which dissociates completely. To form undissociated CH3COH, mind it, small amount you have to add it. Similarly, if you add, that is strong base, small amount of strong base, let us say NaOH, got it, which will give you Na plus plus OH minus, got it, Na plus plus OH minus. So what is going to form here? That is this this particular one, CH3COO minus. Alright, will react with Na plus to form again CH3CONa, which will again dissociate to give you CH3CO minus. Again, the concentration of the product is increasing and due to common ion effect, and the equilibrium is favored in backward direction. This is with Na plus. Alright, CH3CO minus will react with Na plus to form CH3CONa. Again CH3CONa, as that strong electrolyte, it will dissociate to give you CH3CO minus and Na plus. So due to common ion effect, what will happen? The equilibrium will favor in backward direction. The same thing is going to happen. Fine. Now with OH minus, what is going to happen? OH minus will react with H plus ion. Or OH, what you can say, OH minus will react with NaOH to form again, that is Na plus and OH minus. Got it? OH minus may react with Na plus ion to form NaOH, which will again dissociate. Again it will react. Got it? Or OH minus will react with H plus ion to form what? Water. OH minus, generally OH minus will react with H plus ion to form water. Water, what it will do? Will it change the pH? No, because water just changes the dilution of a particular substance. It will make the solution more and more dilute. It will not change the pH of the solution. We can say that. So hence the pH remains the same. This is the buffer action of an acidic buffer, so to say. We can say that. Now we will come to, that is, we will calculate the pH of the buffer solution. Now this is what I am going to say you is the Henderson's Hasselbalch equation. Alright, what I am going to say you now, it is Henderson's Hasselbalch equation, or we call it as also Henderson's equation also we say, no problem. So what is that Henderson's Hasselbalch equation? Well, first let us see for acidic buffer. Now in case of acidic buffer, in general, acid is what? HA, I have said you earlier only. Base will be BOH, alright, and salt will be BA, we can say that, fine. So HA plus water will give you, that is nothing but H3O plus, water react with H plus ion to form H3O plus A minus. Alright. Now next is, we'll calculate the Ka. Ka is what? Concentration of H3O plus, because it's an acidic buffer now. So Ka, if it is basic buffer then Kb into concentration of A minus by concentration of Ha. Now concentration of H3O plus is equal to Ka into concentration of Ha by concentration of A minus. Now let me tell you, Ha we got it from acid and A minus we got it from a salt. The concentration of A minus is from a salt, because A minus reacts with B plus to form a salt, we can say that. So this concentration we have got it from the salt and this concentration we have got it from the acid. Mind it, from the beginning itself I am saying it. Now I will multiply minus log to both the sides. I will multiply minus log. So minus log H3O plus ion concentration is equal to minus log within bracket Ka into, that is concentration of Ha by concentration of A minus. Fine. Now minus log H3O plus ion, what is that? That is nothing but pH. Minus log H plus ion, minus log H3O plus pH. pH, this is log A into B. So log A plus log B. So minus log Ka minus log, that is Ha and A minus. Now what is minus log Ka? It is pKa. And this one, what I said you, this we got it from an acid, it's very clear. And this A minus, the concentration is from a salt. Alright, the A minus concentration we have got it from a salt, because I said you this is an acidic buffer. What is an acidic buffer? Acidic buffer, it's a salt, a weak acid. It's a, what you can say, it's a weak acid, it's an equimolar mixture of weak acid and it's salt with a strong base. So from the salt we have got this particular one. So I can write this as acid by salt. We can write it as, now if I make this plus, this minus, if I change it to plus, it will be plus log, I can write it as salt by acid. This is minus log acid by salt. If I make this minus as plus, it will be what? It is nothing but log, instead of, let me write it here. It is acid by salt. Acid by salt, we can say that. Instead of acid by salt, if I make this as plus, it will be what? Nothing but it will be salt by acid. Let me write it properly. Let me rub it from the beginning. I hope you have written it. Let me write it properly, this one. So pH is equal to, from the acidic buffer you got it, pKa plus log concentration of salt by concentration of acid. That I have written it here. pH is equal to, this is your Henderson's equation for which type of buffer? Acidic buffer. For acidic buffer we got it, pH is equal to pKa plus log concentration of salt by concentration of acid. For basic buffer it will be POH. POH is equal to pKb. Instead of pKa it will be pKb plus log concentration of salt by concentration of base. Now how to calculate pH? You know, once you get POH, pH plus POH is 14. 14 minus POH will give you what? pH. Alright. So this formula is for Henderson's equations for basic buffer. This formula I have derived it already. This is for acidic buffer, so to say. Now instead of what you can say, this salt by base, I can write that is nothing but, that is salt by base, the base will be there. Here instead of salt I can write it is a conjugate acid. Got it? I can write it's a conjugate acid. And here also same thing, I can write it's a conjugate, that is base by acid. Alright? What I am saying you, pH is equal to pKa plus log conjugate base by concentration of conjugate base by concentration of acid. You read it, conjugate acid and base, I have told you. Similarly, pOH is equal to pKb plus log concentration of conjugate, if it is a base, this is conjugate acid, by what you can say, concentration of conjugate, concentration of base. Again I repeat, pKb plus log, that is concentration of conjugate acid by concentration of base, and this will be pH is equal to pKa plus log concentration of conjugate base by concentration of acid. We can say that. This also can be used if conjugate acid and base is being given to you. In this way, this is known as your buffer solution. Last is your buffer index or buffer capacity. It is defined as the number of moles of an acid or base required to be added to 1 liter of the buffer solution so as to change its pH by unity. Again I repeat, that is nothing but buffer capacity or buffer index is nothing but, it is defined as the number of moles of an acid or base, that is required to be added to 1 liter of the buffer solution so as to change its pH by 1 or unity. We can say that. So buffer capacity or buffer index is equal to number of moles of acid or base added to 1 liter of the buffer by changing pH. Again I repeat, the formula will be buffer capacity is equal to number of moles of acid or base added to 1 liter of the buffer. Buffer capacity is equal to number of moles of acid or base added to 1 liter of the buffer by changing pH. By changing pH, we can say that. That will give you the buffer capacity or buffer index. This is all about. Thank you.